Hi, it's Gadget UK here again. Another donation from Keith McGerr here. He sent me this about 6 months ago, I think, actually. I just haven't had a chance to look at it yet. So I'm gradually working my way through some of the things, and he did send me a number of things, and those will be upcoming videos. One or two of them you've already seen, like the clip box. So you can see there's a bit of sticky tape on the connectors here. These need cleaning off. A bit of sticky tape there is removing. So I'll give this a bit of a wipe with IPA before I start. But as you can see here, it's an A500 Zorro 2 Edge version 0.2 from Matthias Heinrichs. So very cool. Is that Matzi? I think it is. So yeah, very cool products. So the idea is, you can see I've got some Zorro connectors of various sizes here. These are the ones that go to the side of the A500. So you have one on one side, it plugs into the side of the A500, and then you have a full size Zorro slot here, and you can stick a Zorro card in. And as it says there, it says use only one DMA card, use no eInt Z2 card. So it doesn't support Zorro 2 cards that use eInts, whatever that is. It has a 7.4 series chip here. I've got one of those here. I did order two actually. I've given one to Sparks UK because I gave him some of the sockets for this so he can build one himself if he wants. And then the only other components are some capacitors and resistors, a diode. So one or two of these things I'm not really going to need to fit. One or two of them I may need to fit. Because ultimately I think that there's a relay goes here, and you have a little floppy power connector. So you feed in 5 volts and 12 volts. When the Amiga side powers on, switches that relay, which engages power to the Zorro side. Now if you saw the A500 repair video I did, the first one, when I just got the bare board, we had some interesting problems with the power, didn't we? And ultimately what I ended up doing was tapping off the 5 volts and 12 volts from the A500 side under here, because they are passed to this, and just join them up to the various points. So I can do that, I can join them up here, which means I don't need to populate any of this stuff around here. Now of course you are then putting your A500 under an extra load. I might try the A2091 actually, because that's the equivalent of fitting an A590, and we know that works without, you know, just using the power straight from the A500 motherboard. So I think I'm going to be okay doing that, but you know, if you're using power hungry devices, you need to make sure your power supply you're using with your 500 is up to the job, because they're not all the same. Some of them provide about 3 amps on the 5 volt rail, and others 4.5 amps, and it's the 4.5 amp one you want if you're going to directly tap the power from here. But the way, as I say, this is designed is to provide 5 and 12 volts and have the relay and all other passives and things around here. I just need to do some connectivity tests on these resistors to see where those go. They may just be pull-ups or pull-downs, and also that diode there, I'd like to check what that diode is doing, but I am guessing we can literally just install the chip, install the 2 sockets, and we are done. So these sockets here, the ones for the Amiga side, you know, going to the A500, you need 86 pin. These are available on AliExpress. Now you can see you've got to solder it like that. I'm not sure if that's the right side actually, just looking at this. I think it probably is. So you've got to solder it on, but it's floating. Can you see that? So what you've got to do is bend the pins down on both sides to meet the PCB like that at an angle, yeah, on both sides, and then just use lots of solder to make sure it's nicely adhered there. And obviously you want it fairly central in between that. So I'll start by bending these, I think, and soldering that on. It's not keyed this, so you can get it either way around. And the other connector you need, again, available from AliExpress. Not sure how many pins these are. That one's a bit bent there, look. It's because it's been in that bag, it's not really the right kind of storage for something like this. Yeah, a Zorro 2 connector. So I mean, these are the sort of things you get on, you know, obviously A2000 motherboards, or an A3000 I think. But anyway, those are the same connectors, so you can see that's going to be really easy, isn't it? Just solder it on. So I removed that bit of tape there, but you need to just clean these edge connectors up here. And of course, the reason there's 2 here, you've got a pass-through. So one test I might do, I'll disable the RAM on the A590, connect the A590 up on the pass-through connector, and then connect an 8 meg RAM board up to the slot. Now in theory that might work. I don't know whether it will, because it says 1 DMA card, and actually those are 2 DMA devices, I think I'm pretty sure the RAM supports DMA, could be wrong. So yeah, I'll just clean those marks off, and then the solder points should be pretty good when we come to put the connector on. It's tinned on both sides, that actually, you know, the pass through and the bit you want to solder your 86 pin slot connector onto. So I need to go and have a look at some photos of this now, just to make sure I do get this the right way around. It could be that way, I think, but it might be that way. So the way I did this is just went down here and squeezed. There's one or two there that are just a little bit close together. They just need separating a little bit. They're not very regular. Because the gap is less than the PCB, you can see there's no way I can get that on. So what you've got to do is start at one end like this and then just wiggle like that to slide it on. And if you get to a point where it's not moving, there you go, just wiggle a little bit further. You can see that that is going on, and it's going to be tight. Can you see that? The pins here are all gripping really well on both sides. The key then is just to hold it dead straight. I'll show you that in a second. And just add lots of solder and lots of flux, and just anchor a couple of points and make sure it's straight. You know, it's 90 degrees. It gets a bit more difficult to wobble it when you get to this point, because all the pins down here are kind of holding it. If we just slide that further up, we're almost there, look. Last few pins here. There we go. And if we just put it into position, there we go. Hold it. So you can see they're all, you know, really taut there. They're all flat at the point of the tip. Now this is where you do need to make sure you've got lots of solder though, because if you don't get lots of solder down the length of this and all under the angle, you know, the part where it's lifted off the PCB, you know, under this part here, any pressure, you know, you could damage your connection. So I'll just hold that there like that, and it does go this way around, by the way. The power seems to come in from the top side there, and obviously it goes into the left hand side of the Amiga. So I'm going to use this thick solder here. It came from my good friend Dr. Andrew. It's a huge reel, let me show you. It's giant. But I figure, why not start to use it on things like this, because, you know, it's a bit too thick for some of the small SMD stuff I do, but with things like this we need lots of solder, don't we? So it makes perfect sense. So I'll just blow a crazy amount under there. I want a really nice beefy connection. So you can see straight away that is not straight. It needs to be heated and just pressed that way a little bit. Of course I can get some flux on these and flow these at the end. That's a bit straighter, but it's pointing down towards the iron here, look. So yeah, this is where just a little bit of trial and error may be required to get it as straight as you can. Yeah, that's pretty straight now. And it's pretty straight on that side, so let's do that side. Yeah, I'm happy with that. We can always just heat the odd connection up and just bend it a little bit in a sec. And what I mean by that, as I heat this here, I'm just going to put a little bit of pressure on it, just to try and straighten it a little bit. I'll let that set. Yeah, it still needs a little bit more, because can you see it's kind of pointing down this way just ever so slightly. It's so subtle, and if you've soldered too many connections, adjusting it would be very, very difficult. Yeah, that's straight. So I'll just reflow that side now to release the tension. You can hear it click there when I did that. There we go, dead straight. That's dead straight. We'll just heat that again. It clicks there again, look. Yeah, that's okay. And a little bit of solder on here. Yeah, there we go. That is going to be perfect. So I will just proceed to soldering these all up. Because I'm using a lot of solder here, and it does contain flux, you can see it, I can smell it. It's, you know, there's a chance if you get just a bit too much, you may end up joining things together. Both sides soldered on. I'm just using the toothbrush here. I did go over with a cotton bud originally, but you can't get into the gaps and things. So that is looking pretty clean actually, as you can see. Just need to do the other side now. So we're all cleaned up there now. The next thing is a socket. Still a bit of IPA there, you can see that, a bit of a streak. Yeah, I'm going to get a socket on. You could just solder the chip straight on, but yeah, I always like sockets, because then if something does go wrong, let's say I kill this chip, or this chip doesn't work because it was purchased from eBay, so, you know, it could be a fake, it might not be the ACT that it's supposed to be, etc. If we solder a socket on, it's just going to save us so much hassle, isn't it? Having to take the blooming chip back off again. So I may need some resistors for this, or a diode or something yet, I'm not sure. I'm going to go do some connectivity tests next, I think, work out where they go. The ones that are, you know, the positions, what they're for on the board here, and work out myself whether I think they're needed. Because what I'm trying to do with this build is make this as simple as possible. I really don't want all the extra power things and relays and all that. It is useful depending on what you're doing with it, but for what I'm doing with it, I just want to be able to just easily plug something in and power it from the Amiga. Oh, it's getting really sticky, this. It's like sticking to my fingers. Not even sure if the IPA is having a reaction with the socket, to be honest, because it's the socket I keep getting stuck onto. Yeah, that's not too bad. So we've got 100 nanofarad cap there that we do need. You can see I put the chip in, and I fitted R1 and R3. Those are 10k. Now I've checked those. I think they are pull-ups. The interesting thing is they go under here. Sorry, pull-downs. They got to between ground and one of the signals here. So that's a bit weird, actually. I can't quite work that out, but I think those are needed. Assuming they are pull downs, because one side definitely is ground, but it doesn't seem to be anything to do with this. Now all the components around here are to do with the power stuff, so we can I'm going to ignore all of that stuff around there. None of the caps. We don't need the resistor, we don't need the transistors, we don't need the relay, we don't need the diode. So the only thing I'm going to do now is get the socket on and then just wire it across the 5 volts and the 12 volts. You can't get this round the wrong way because it's not keyed or anything like that. Yeah, that's it. You can see why it's a good idea to perhaps get these things in first. So we're nearly done. I just need to work my way through the 1,000,001 connections on here now. One thing with these, I've tried the other way in. Maybe it's this solder. Let me just try and change to my other solder. What I'm finding is it's not flowing very well. It could be the flux in that solder that is the problem. It's old solder, because flux has a best before date, believe it or not. I'm assuming it's the same. There we go. In rosin core flux, you know. It's interesting. There's a couple of little pins right next to this here. I assume you need to short to one of those or the other. Anyway, I'll report back in a little bit when I finish this. So just making sure the A500 Plus still works, and it does. So switch it off. I'm just going to try it with this on its own, with nothing else, and just make sure that chip is not red hot. Switch it on. That IC is okay. System is working, so it's not caused any problems. This CPU is a bit loose in this socket. I really need to replace it with a turn pin socket because it's had turn pins in it. Anyway, the next thing to do, I think, is try it with the A590. Oh, behold, a nightmare. Is this going to work? Just doing a sense check, nothing's shorting. Switch it on. Yeah, can you see that? So the A590 is working as things stand. I'll let that boot up and just make sure the system is behaving as normal. But the main thing is that proves that the 5 volts and the 12 volts, well, we don't know about the 12 volts because this doesn't use it, but the 5 volts and the 12 volts are going across there, and it is seemingly booting. It's got me puzzled what these two 10Ks are for here, because you know what, you don't normally have them. It could be interfering with this now, actually. Let's just see if it boots. Yay, that worked. So you can see the RAM is disabled on it at the moment. So if I switch that off, Now the important bit is, what is an e-int card? I have got no idea. What I do know is I've got a Zorro 2 card here somewhere, if I can find it. So again, this will be part of a separate video. I'll stick a link up there to it. Now the front of the machine on a 2000, it goes like that. So I am guessing it goes the same way here actually. So let's fit that in. Now this is set to 8 meg. So if we just do a sense check there, just make sure everything's in. I'm just looking to see if there's any indication on this, whether this is front or back. That's got to be the front. It'd be stupid to have it the other way around, I think. So let's just try that. Yeah, IDE's booting. So far no issues. Let's just see if it boots and see if we have 8 meg. It's a bit of a strange setup here, isn't it, with the A590 and the RAM board and, you know, all on a box. It's a bit crazy. But of course, this is all just for testing purposes, the way this is set up. But I guess the useful thing is, if you've got an A590, it means that you could plug certain types of Zorro card in there. I might do a little bit of research in a minute to see what this e-int stuff is all about, and perhaps what cards may cause an issue. We're going to find out pretty quick here. Let's have a look. Hey, we've got 8 meg, look. That's worked. So let's go into sysinfo and have a look at boards, I think it is. Look at memory first of all. So we get 8 meg fast, kick DMA, 2 meg chip. So that's all correct. And if we look at boards, yeah, look, we've got the A590 and we've got an 8 meg Zorro 2 board there, the one from Live 2. So that is fantastic. I think the next thing we'll do is we'll try the A2091. We'll remove the A590 and we'll just try it with an A2091 to see if the Zorro slot works. So we'll just make sure that's nice and firm on there. And then we'll try Booty McBooterson here. Hang on. Now the problem here is the card is got to be over the end of the box, so I'm going to have to try and move everything around here. So you can see what I mean. I had to pull it over the edge of the box here because the card is obviously going to stick into something there. You know, if you have this on a table, you'd have a problem. You'd have to remove the thing there. But I actually think if you're going to stick this in a cased 500, you'd be crazy to stick a full-length Zorro card like that out the side of your 500. It's the sort of thing that's great for testing, and it's also useful if you've got like some sort of case build where you've got your 500 in a, I don't know, a PC case where you've hacked away at the metal and stuff and managed to fit it in there. Yeah, you could do something like that and use a Zorro card. So let's switch it on, and that is working. You can see the LED here flashing. So that does seem to be booting. Now this is going to provide just the same thing as the A590, 2 meg RAM and the SCSI there. Before anybody asks, there is literally no point in connecting up the A590 and the A2091 at the same time, because I'm pretty sure that will not work. And that works perfectly. This is obviously streaming straight from the A2091, as you can see. It really is a Frankenstein of hardware, this, isn't it? That's with the Pi Storm. And actually the 2091 will work with it. I think we're going to have a clash on the RAM, but we're going to have, I think I've got enabled 8 meg of Zorro 2 on this actually. So it's going to just probably either have 2 meg or 4 meg or 8 meg or something. I don't really know what will have happened with auto config. We'll find out in a minute. But then we've also got 128 meg of Zorro 3 RAM. So anyway, it'll be interesting to see if anything will load off this. We'll try TimeGal again. So this is with the Pi Storm. So the Pi Storm is obviously super quick at booting off its own drive, but now if we go to DH4, let's try TimeGal. When I tried this previously, if you haven't seen the Pi Storm video, you'll know that this didn't work when I tried the A590, so it'll just be interesting to see what happens there. It got this far, black screen, and then it just froze here. The same thing is happening. So yeah, there is an incompatibility at this point in time between the Pi Storm and you know, things on the Zorro side, be it the A590 or the A2091 here. Just checking the Pi Storm still works, and it does. Just watch how fast the Pi Storm boots. Control, Amiga, bang, straight back up. If you saw the SID card video, you'll know that this works as well. So yeah, that's another Zorro device that I've been able to test in here, and as you can hear, works fine. I've got some pins I need to take out of that as well, but we'll stick this in next. You can see it looks pretty clean after hand cleaning it, but there is flux in between some of these things here. It's just a little bit sticky in places. It doesn't look too bad actually. And again here, you know, just little bits of flux. You probably won't be able to see it, but we'll give that a go as well. Right, so this has been through the ultrasonic. You can see, you know, the solder on there. It's very hard to get nice flow on that solder to make it look nice and tidy, but you know what, that's come out pretty well actually. And you can see where I've just joined the two wires on here. So the red one is the 5, I think, +5, and the yellow is the +12. So I joined them to the points here. You can see very clearly where I've joined those. I think the next thing I'm going to do actually is just do some connectivity tests around here now and work out if there's one of these cap positions here for the 12 and one for the 5, and I'll fit those. It would be a good idea just to have a little bit of localized smoothing on here, because if you get dips in current from a card that's in here, you see, that's going to back feed into this way into the 500. That little current dip could cause some sort of issue. It's unlikely, but it's a good idea just to have a little bit of local smoothing there. So I mean, you've seen it worked without the caps, but you know what, it's a good idea to have a couple of caps on there. Yeah, so I got a couple of cheap forever caps here, 220 microfarad. Trust me, they aren't forever, but they'll be fine for something like this. I was going to try and fit 470s, but you know what? The positions of these caps here are so close to the Zorro slot that you can't fit larger ones. Well, you could do. You can get 470s that are smaller, but you can see it's going to be tight enough with 220s there. So in terms of connectivity, I'll just show you this, and I'll show you how it works out that these are the two cap positions. So we're on continuity test here. And I worked out the 5 and 12 just by looking at the A500, you know, the pin out actually and the schematics on this connector here. We covered that when we did the A590. You know, it's like the third one and the fifth one on the bottom side. So yeah, 5 volts on the third one, I think. Let's just test that. Yeah, and the 12 volts is the fifth pin there from that side. So as you imagine the Amiga motherboard here, you know, we're dealing with the third one on the underside of the fifth one. But if we just test from this side of the +5 here to these two positions, hang on, yeah, you'll see the left hand pad there, we've got a short, so that's the 5 volts, and the yellow one, I'll do the same thing here, goes to that one, dead short. So these two pads must be the grounds, they're joined together. That's the ground down there. The other thing you could do just to give yourself some confidence that these right hand pads here are ground is just carefully move over there, test from the 7.4 series and see where it connects. Hang on, so it's that one, so it's this pin here. If we flip this over, that's that pin, that is the ground pin. Yeah, sorry if you can't see that, but yeah, that's the ground pin. So we know what we've just done there is correct. Let's just confirm grounds again. Yes, the grounds are the ones nearest the edge of the board here. So let's just check the voltage on these. It's 10 volt. I need a 16 volt because one of these is going to be 12. So I'm just going to change these for something more suitable. Right, I'm going to have to go with the suntan ones, which I didn't really want to use, but you know what, they're alright. They're alright, they're just not as good as Panasonic's. So yeah, ground wants to be towards the edge of the board here, so let's get the first one in. Yeah, you can see they're just stuck out a little bit there. It's quite tight space, but it'll be alright. And I'm nearly out of main roll of solder here, so this is where Patreon support really helps actually, because I'm going to need to go find some new leaded solder. I don't like the unleaded stuff. Technically, if you're building and selling stuff like this legally, you need to be using unleaded solder actually. That is important to note. Well, I say legally, I mean like in terms of trading standards and environment and all that, you should be using lead-free solder. Let's just see what that looks like. Yeah, that's not too bad, is it? It's about as good as I'm going to get for the size, you know, physical size of the cans there. They're both 220 microfarad 16 volt. The original schematics for this may suggest a lower size there, like 10 or 22 or 47, but yeah, I want something a little bit more beefy actually, which is why I started by trying to size up 470s and went with 220s. Yeah, there we go, that'll do. So I'll just clean around there with a bit of IPA, because this has been through the ultrasonic already. So I'll just squash that down just so it doesn't get caught in between this small gap here, which makes it easier just to clean just that little bit. Incidentally, the diode on the other side, you know, I think I mentioned that early on actually, I wonder what that's doing. I think it's probably like a scrubber diode, you know, it's that sort of thing where it's mounted across the coils of the relay. So when the relay is engaged and disengaged, you don't get like a reverse voltage spike on the 12 volt rail. Assuming it's on the 12 volt rail, it might not be, it might be switched from the 5 volt rail. But yeah, I think that's what that diode is for actually. So, you know, you've seen this works without it, and it worked without these caps. This is just a nice to have. And when I was explaining before, I was talking about current dips and things, it's actually about a voltage dip. You get a current spike, you know, there's something on, you know, the card that's plugged in here, maybe you've got the A500 and a memory board or something plugged in here, or a SID card or something, and you can get current spikes as a result of some activity on the cards and things you're using. Maybe you've got a SCSI hard drive or something connected on it, that's going to create some pretty nasty current spikes, and your voltage could dip, and a voltage dip could cause some instabilities and things. So that's a good reason to have some caps there. And I think 220 microfarads is better than smaller, you know, bigger is better than smaller, certainly on the 12 volt rail without a doubt, if you're powering a SCSI drive or something from this. But yeah, that should be fine. And the final test here, because I don't have any more Zorro cards to hand at the moment, is the GVP. There'll be a separate video on this, getting this card up and running. This was a donation ages ago actually, just after I lost my job. But you can see it's booting okay. This provides 8 meg and SCSI via the SCSI 2 SD. You can see we've got 8 meg there. Let's just try TimeGal again, because that TimeGal, I'm not really sure I explained, but I found a scenario whereby it doesn't always run. It's bizarre, and I found it consistently across a few different 2000 motherboards, depending on the hardware you've got. You can copy it to a different drive and it then works. It's just from SCSI. But there, it works okay, as you can see. So the throughput on this card is probably not that great, the way it's configured. Yeah, can you hear the stops and starts? That is one problem I found, and I think what you need there is you need to install the GVP drivers. Actually, it's just using the standard SCSI driver, and I think it runs a bit slow and jerky. You can hear it stopping and starting, but that's exactly what happens in the 2000. But anyway, we'll cover that when we look at this card in the video on its own. But it does work. So a short video this time. Thank you ever so much to Keith McGerr for sending me this PCB. As I mentioned earlier, I got these connectors from AliExpress, 100 pin, 84 pin, 2.54 pitch, and you just need obviously the PCB. You can get these pretty cheap on eBay, about £7. You could get it cheaper if you actually ordered it direct, you know, from somewhere like PCBWay or JLC PCB, whatever they're called. And you need a 74 ACT 86. That's an XOR, by the way. I think that's just for the clock. I think the clock stuff comes through here actually and is buffered through there. I think that's what that's for. And obviously all the stuff up here that didn't fit is just if you use, you know, like an ATX power supply and you put a floppy connector into there. I wouldn't do that. I would shy away from that if you can. Just go with a beefier power supply on your Amiga and pass the power through. My reasoning behind that is, you know, if you saw the A590 video, when we had 2 separate power supplies, and you're still going to have the same problem with this, regardless of the relay, by the way, when you've got 2 separate power supplies, if one of them's linear and one of them's like a switch mode power supply, depending on how those power supplies are built and designed, certainly the switch mode one can vary, where you get differing ground levels if you're not careful. I had that with my power supplies here, and it nearly destroyed the A590 and my Amiga actually. So you've got to be very, very careful. You really want, ideally, one power supply powering everything. because it's all about where the ground level comes from. If it's coming from a transformer, even though your grounds are joined together, as they were in the A590 video, somehow voltages were swinging wildly apart. The point was killing the RAM, so I would not use that. I would not be tempted to fit the relay stuff on there. I would just do what I've done here. But anyway, that's just my view. I do hope you found the video interesting. If you'd like to support the channel, please see the Ko-fi and Patreon links down below. Catch you in the next video.